Hi guys, welcome back. Today we're going to keep talking about solving trig equations, so we're going to continue notes 8.5. So we're going to be solving by factoring today and also solving by using our trig identities. So we're going to be doing two examples for each. Again, I gave you guys the steps in these little boxes. So for solving by factoring, we're going to set equal to 0. So we need to set the whole equation equal to 0. I put a little star next to that one because it's a very important step. You have to make sure you do that before you do any factoring. Step 2, we're going to factor the GCF or use the X method. Typically, we know we have to use the X method if we have 3 terms. Step 3, take the inverse or again use your unit circle to find the angle. So remember last time we talked about whenever we have a trig function equal to some value, we have to try to find that value on the circle, and that's going to be our angle. That's going to be our final answer. Or you could also take the inverse on your calculator, but remember that usually only gives you one of the answers when there's typically more than one. So it's up to you what you want to use. I prefer the unit circle, so make sure you have that out with you. If not, Google one so you can use one as reference. All right, so number 1 is cosine cubed x equals cosine x. So step 1 says to move the cosine over to the left side because I need to set it equal to 0. So I'm going to subtract cosine x from both sides. So that goes away. I'm left with cosine cubed x minus cosine x equals 0. I can't combine the cosine cubed minus cosine x. I can't just say that's cosine squared because they don't have the same exponent. It's like saying x cubed minus x gives me x squared. We know that's not true. Same rule applies for trig functions. So now step 2, factor the GCF or use the x method. Well, I only have 2 terms, so I know I'm not going to use the x method. I'm going to factor a GCF. So the greatest common factor is that they both have cosine in common, so I can factor out a cosine from both of them. Whatever the GCF is comes out to the front, and then I divide. So cosine cubed divided by cosine is cosine squared. And then cosine divided by cosine is 1, so I have minus 1 equals 0. Now I have two separate equations, so I have cosine x equals 0, and then I have cosine squared x minus 1 equals 0. So cosine x equals 0, that's asking me at what angle is cosine, or is the x value on the unit circle equal to 0. So if you look at your unit circle, the x value is 0 at 90 degrees and at 270 degrees. Remember, we also want the radians, so pi over 2 and 3 pi over 2. All right, next one, cosine squared x minus 1 equals 0. I have to solve for cosine. So cosine squared x equals 1. When I move the 1 over to the other side by adding, take the square root. Cosine x equals plus or minus 1. Remember, when you take the square root, you have a plus or minus answer. So now I'm looking for the angles on the unit circle where the x value is either positive or negative 1. So that's 0, 180, or 360 degrees, which is also 0, pi, and 2 pi. So there's our final answers for number 1. Okay, let's do number 2. So number 2, we can see that we have 3 terms. So we know we're going to be using the x method. It's already set equal to 0, so we don't have to worry about moving anything. Everything's already set equal to 0. We're going to have to factor using the x method. So the tricky part, usually with students also always struggle with seeing the trig function. Like, how do you factor a trig function? Well, just pretend it's not there for now. Pretend I'm factoring 2x squared minus x minus 1 equals 0. So essentially we're replacing the signs with x, just so you guys can see what I mean by factoring a trinomial. We can all factor this, so remember you have to multiply 2 times negative 1. You get negative 2, and our middle term is negative 1. I need 2 numbers that multiply to negative 2 and add to negative 1. So that gives me negative 2 and positive 1. So negative 2 times positive 1 is negative 2, and then negative 2 plus 1 is negative 1. So that works out. So now I'm going to write my binomials. So I have x minus 2 and x plus 1. Don't forget this part. Remember, because we moved this 2 over, we multiplied by 2 times negative 1, we have to bring it back at the end, so we have to divide by 2. So this gives me x minus 1. And when I can't reduce the fraction here, remember I have to bring the 2 to the front as a coefficient, so I have 2x plus 1. And remember, this is all still equal to 0. It just drops down. Okay, so now we factored it. So now we have to bring back the sine function though, because remember that's what we were looking for was a trig function. We replaced sine with x, so I can bring it back and replace all the x's with sine. So I have sine of x minus 1 and 2 sine of x plus 1 equals 0. Now it's a problem like in number 1 where I have two separate equations. I need to solve for sine and then find those angles on the circle. So this is sine of x equals 1, and this will give me sine of x equals negative 1/2. I just subtracted 1 and then divided by 2. So now let's look at our circle. We need to find the y values where we have 1. So we're looking for at what angle is the y value equal to 1. So it's at x equals 90 degrees or pi over 2. And then for the y values at negative 1/2. So we're looking for the angle where y is negative 1/2. So that's going to be 210 and 330. And remember, we again want the radians. So at 210, the radians is 7 pi over 6. And at 330, it's 11 pi over 6. So those are our final answers for number 2. So factoring just requires a lot of prior knowledge of factoring a GCF and a trinomial. So just take some refreshing of your memory and you'll be fine.